Hey, hi everyone, welcome to the channel Code Library. So, today we'll be solving one problem, that is kth largest subcontiguous sum. So it's pretty much similar to the question, that is largest sum of a subcontiguous array. So it's kind of that only, but it's just now they are wanting that kth largest. From kth largest, kth minimum, it's very much prominent that someone might be using heap or min heap, or I mean like uh, there's alternate way also for kth largest maximum sum is that you just sort the array and just return that. Sort the array in a descending manner and just return that kth index value. So I'll just read the problem statement. First, the problem statement says is. So the problem statement says that you are given an array of size n. You have to find the kth largest sum of a sub-contiguous sub-array within the array elements. So again, I said it's clear that we have to generate all the sub arrays, because we have to if we are going to generate all the sub arrays, then only we are going to be able to get all the sums. And if the array size is n, then definitely the number of sums, I'm saying that the number of sums that would be generated would be n into n plus 1 by 2. Why? Because if you take single subarrays and single element subarray, that will be 1 1 1, that would be n, and then 2 2 2, then that would be n minus 1, and then if you go like this, it will be a summation of n numbers. So that would be n into n plus 1 2 and 1 by 2, n into n plus 1 by 2. So that's very clear that we have to generate n into n plus 1 by 2 sums. So definitely that sums would only be generated if you generate the subarrays. So right now what I did is I use the same. I generated all the subarrays, and in subarrays will be generated, as I say, subarrays generation time is n square, because you will be generating n square subarrays. And now comes to the question that every subarray will be generated. Now let's say the subarray size is n by 2. So element ka sum, that how you will be calculating. So for that we have used a logic that is called prefix array. So it's not a very big fancy concept. So basically what you do is at every index, prefix array, what does it at any point in prefix index, it will store the sum of all the previous elements. Okay, so how does it help? Okay, so let's say as I said, the problem main problem was that, let's say you got the sub array, but how to calculate the sum in O1 time? Because if you are not going to calculate the sum in O1 time, then it would be O(n) cube, because the sub array generation time is n square, and in every sub array generation it will be we have to calculate the sum. So we'll be multiplying that again to the n, that n square into n, that would be n cube. So that is very prominent, that how can we use that. So yeah, that's why we are going to target in O1 time. So that's why the reason we are using the prefix array. So in prefix array, what we will do is, at any point in the prefix array, at any index, uh, the value that will be stored in the prefix index will be the sum of all the elements before that element. Okay, so how does it help? And let's say in the problem, there is a subarray and we have to find the sum in the O(n) time. So what we will do is, let's say we have an array that has starting index 2 and subarray ending index is 6. So what we'll do is, we will get the prefix array value which is at 2. We will get the prefix value array at 6. We will subtract those values, and since prefix of 6 will not contain that sixth value of the array, we will add that value. So this is how the formula comes up, that is, we'll prefix of 6 minus prefix of 2 plus value at 6. Okay, value at 6th index. So how does it helps? It will give you the sum in the difference in O1 time. After that, what we'll do is, we will as I said, we'll not be using sorting algorithm, we'll be using a min heap. So we'll put the elements one by one in the min heap until the min heap size does not get k. Once it gets k, we will just have a check. Will in the code itself, you'll see what kind of check is applied. There is a special kind of logic behind that kind of check. We will discuss it in another video. So we will just check that and then put it on, and we have to make sure that the heap size, mean heap size, retains k only. And yeah, that's it. Then at the end of the for loop, when you generate all the sums and you push the elements in the queue of size k, okay, some elements would be popped out definitely. to make sure that the size remains k. It does not get n into n plus 1 by 2. And finally, at the end of the day, you just have to return whatever it is after 2. That's it. So there's a another logic that says that you have to find the kth minimum in a if you have to find kth maximum. Okay, so what we do is rather than sorting, because kth max, one way is just sort in a descending manner, that you will get. Another way is you just use a min heap. Rather than sorting one by one, put the elements into the queue. Once the queue size gets k, after that apply a check. That kind of check is decided in the code. It's described in the code properly. So that kind of check, if you will apply, you will just run the loop, you will get the idea. Yeah. So all the best, guys. Thank you.